Welcome to G Fun Facts Online, where we find the order in the chaos. And today, we're going to talk about why complete chaos might actually be impossible. In a universe that often seems random, a deep mathematical law guarantees that patterns will always emerge. This is the world of Ramsey theory, a branch of math that proves that in any system that's big enough, structure isn't just likely, it's inevitable. From who you hang out with at a party to the shape of entire galaxies, the echoes of Ramsey's theorem are everywhere, telling us that true, absolute disorder simply cannot exist. So what is Ramsey theory? At its core, it asks a simple question: how big does something have to be to guarantee a certain pattern appears? The most famous example is known as the party problem. Imagine you're throwing a party. How many people do you need to invite to guarantee that there's a group of 3 people who all know each other? OR. A group of 3 people who are all complete strangers. Think about it. With 3 people, it's not guaranteed. With 4 or 5, still not guaranteed. But mathematicians have proven that once you have 6 people in a room, it is an absolute certainty. You will always find either a trio of mutual friends or a trio of mutual strangers. That magic number, 6, is called the Ramsey number R, 3, 3. It's the tipping point where a specific social pattern must emerge. This sounds like a fun little puzzle, but it's the gateway to an incredibly complex field of mathematics. Figuring out Ramsey numbers for bigger groups is notoriously difficult. The legendary mathematician Paul Erdos once said that if aliens threatened to destroy humanity, unless we could tell them the Ramsey number R, 5, 5, we should gather all the world's mathematicians and computers to try and find it. But, he said, if they asked for R6, 6, our only hope would be to fight. That's how hard the problem gets. And for nearly a century, progress in finding these numbers has been incredibly slow. Until now. In March 2023, a team of researchers, Marcelo Campos, Simon Griffiths, Rob Morris, and Julian Sahasrabudhe, announced a massive breakthrough. They found a new, much tighter upper limit for Ramsey numbers, the first exponential improvement on a formula that had stood for over 80 years since it was first proposed by Erdos himself. People in the field called it absolutely amazing, something they never expected to see in their lifetime, and the breakthroughs didn't stop. Shortly after, mathematicians Sam Mateus and Jacques Verstraete solved another long-standing Ramsey problem using new methods involving things like pseudorandom graphs and finite geometry. It's like a dam has broken, and a flood of new techniques is giving us fresh hope that we can finally start to crack these fiendishly difficult problems. But this isn't just about abstract numbers. This is where it gets really cool. Ramsey theory acts as a powerful metaphor for a universal truth. In any large and complex system, patterns will inevitably emerge. Nature is the ultimate proof. Think about the mesmerizing spiral arms of galaxies, the unfurling of a fern, or the shell of a nautilus. These beautiful shapes often follow mathematical rules, like the Fibonacci sequence, where each number is the sum of the 2 before it. This sequence appears in the arrangement of seeds in a sunflower, providing the most efficient way to pack them in. Nature didn't read a math textbook. It found the optimal pattern through evolution. We see it everywhere. The perfect 6-fold symmetry of a snowflake. The bilateral symmetry of a butterfly's wings. The fractal branching of trees, rivers, and even the blood vessels in our own bodies, where similar patterns repeat at smaller and smaller scales. These are all examples of self-organizing systems, where complex global patterns arise from simple local rules and interactions. So what's the direct link between a party puzzle and a spiral galaxy? While a galaxy isn't literally solving a Ramsey problem, the underlying principle is exactly the same. Ramsey theory gives us a mathematical guarantee that order is an inescapable feature of large systems. The universe, with its trillions of stars and countless interacting particles, is the ultimate large system. Just as a clique of friends is inevitable at a party of 6, the emergence of patterns, whether it's the crystal structure of a mineral, the stripes on a tiger, or the vast cosmic web connecting galaxy clusters, is a fundamental, built-in feature of our reality. These recent breakthroughs do more than just refine some numbers on a blackboard. They reinforce a profound and comforting idea. The universe is not just a meaningless sea of chaos. Hidden inside its complexity are rules that give rise to structure, predictability, and beauty. The work of these mathematicians gives us a sharper language to describe this inherent order. The search for these truths is a deeply human quest to find patterns and make sense of our world. It shows us that from the chatter of a social gathering to the silent dance of the cosmos, there is an underlying harmony, an inevitable beauty born from the simple laws of logic and number.